Here I have a problem from the AIME 2007 math contest. And it gives us this definition for z, where z is equal to 9 plus bi, and b is a positive integer. So let me go ahead and note that here as well, that b is in the integers. The problem also tells us the imaginary part of z squared is equal to the imaginary part of z cubed, and asks us to find b. So let's jump into the solution. First, what we want to do is expand out z squared and z cubed. So z squared is going to be equal to 9 plus bi all squared, but that's going to be 81 plus bi squared, so that's b squared times -1, given that I is equal to the square root of -1. But then we have the terms in the middle that are combined. That's going to be 2 times 9 times bi. So we don't really need to worry about the stuff on the left-hand side of this. We only have to worry about 18bi because that's the imaginary part. So I'll go ahead and make a note of that here. Imaginary of z squared is equal to 18bi. Now let's look at z cubed. So expanding out z cubed, we get 9 plus bi cubed. But that's going to give us 9 cubed. That's 729 plus bi cubed. That's b cubed times -1 times I. And then we're going to have the two middle terms. We'll have 3 times 81. That's 9 squared times bi. And then we'll also have 3 times 9 times b squared I squared, but that's b squared times -1. But now we don't need to worry about this part or the 729, we only need to worry about b cubed times -1 times I and 3 times 81 times bi. So I'll go ahead and make a note of that the imaginary part of z cubed is equal to b cubed plus 243b times I. So on the next board, what we'll do is we'll compare the imaginary parts from z squared and z cubed. So in the last board, we found the imaginary parts of z cubed and z squared. And I went ahead and corrected a mistake I think I made on the last board of not attaching this negative to this b cubed in the final writing of the imaginary part of z cubed down here at the bottom. But I fixed that here. And now to finish this problem off, we need to set them equal to each other. So I'll have 18bi equals 243b minus b cubed all times I. But now we can divide I out from both sides and we just get 18b equals 243b minus b cubed. And then subtracting 18b from both sides, we get 0 equals 225b minus b cubed. And now factoring b out of this right-hand side, we get 0 equals 225 minus b squared times b. But now one of these two terms has to be equal to 0. So we have b equals 0 from this right-hand side equaling 0. And then we have plus minus 15 from this 225 minus b squared equaling 0. But because we were given this restraint of b having to be greater than 0 here at the beginning, we know that b equals 15 is our only possible solution here. And that's enough for now.